Section 1.1 is on simple interest. We're going to be working through the notes handout that you have together, and then at the end you'll have some in-class time hopefully to work on the assignment. So let's get started. By the end of this lesson, you will be able to understand and calculate simple interest. To do this, you will need to understand a few different terms. The first one is the word term, and when we're talking about interest and money, the term is the predetermined length of an investment or a loan. It's the amount of time essentially that you hold the loan for. So if you're talking about a mortgage, sometimes the term is 20 or 25 years. If you're talking about a car loan, maybe you're looking more at like 5 years. It all depends on the instance in which you are borrowing or making money in terms of perhaps a GIC or something like that. The next one is interest. Interest is the amount of money that you earn. So if you're talking again about a bank account or some type of investment, or the amount of money that you pay during the term. So if you're talking about a loan of some kind, then you would be paying interest. The next one is a fixed interest rate. I've underlined the word fixed here because that means that it's guaranteed not to change during the term. Lots of people will choose to lock into a fixed rate to avoid the risk of a fluctuating interest rate. Typically, though, when you're talking about fixed interest rates, you may not necessarily get as good of a rate as if you were to take the chance on a fluctuating one. The next one is the principal. The principal is the original amount of money, the amount of money that you're starting with. Simple interest, which is what we're going to be talking about only today, is the amount of interest earned, or again, the amount of interest paid, based on the original amount and the simple interest rate. The reason it's called simple interest is because it's calculated very simply. There is just one flat formula, there's no changing, there's nothing making it complicated, it's just straight up do it one way. Lastly, the rate of return is the ratio of money earned, or again, the ratio of money lost relative to the amount of money invested. It's usually expressed as a decimal or percent. Underneath here, I'd like you to put the rate of return, and we're going to write it as a ratio. So it's the amount of money earned or lost divided by the amount of whatever your principal was. When you calculate that, you're always going to get a decimal answer. We'll typically change that decimal answer to a percent by multiplying it by 100. So write this underneath your rate of return definition. All right, next, interest rate is calculated using the following formula. I should have probably added in here that the simple interest is calculated using this formula. I is equal to PRT. In this formula, the letters are representative of these following terms. I is the amount of interest that you're going to either earn or lose, depending on if you're talking about an investment or not. The capital P is your principal, the amount of money that you're starting with. R is your rate. Your rate is always going to be expressed as a decimal. So if you're talking about, let me just make that a little bit smaller. If you're talking about 5%, your rate is going to be 0.05. Remember that to change percent from a percent to a decimal, you always divide by 100. So if you're talking about 4.5% as a decimal, that's going to be 0.045. All right, and T is your time. So if you have the investment for 5 years or 10 years, if you have the car loan for 5 years or 7 years or 8 years, that's going to be your time. All right, moving on. Example number 1, Marty invested in a $2,500 guaranteed investment certificate. So this is a type of investment that you can buy through a bank, typically also known as a GIC. He's earning 2.5% interest, simple interest, and it's paying it annually with a term of 10 years. How much interest will accumulate over the term of Marty's investment? So we're using this formula of I is equal to PRT. Within that formula, to calculate it using simple interest, all we need to do is fill in what we know and solve for what we don't know. The nice thing about using these formulas is that there's only ever going to be one thing that you don't know. Most of the time when we're doing simple interest, it's going to be how much interest did we accumulate, which is I. Sometimes you're going to have to solve for R or T to find the missing rate or to find the missing amount of time, but that just comes down to your prior knowledge of being able to solve equations. So, principal in this case is $2,500. Our rate is 2.5%. Remember that we need to change that to a decimal. We need to divide it by 100. When we divide it by 100, what we're doing is moving that decimal place 2 spots to the left, and we're getting decimal 0.25, and multiplying it by the time, or the term, which is 10 years. When we do that math, 2,500 times 0.025 times 10, we're getting $625. Okay? Part B of this says, what is the future value of his investment at maturity? Future value is the amount of money he's going to have at the end after he's accumulated all of that interest. We abbreviate that with capital F, capital V. His future value is going to be calculated by starting with his initial principal, which was $2,500, and adding his interest, which was $625, and we're going to end up with $3,125. All right. I want you to pause this for a moment, take a couple of minutes to try this bottom question on your own, and then press play again and I'll have worked through it for you. So again, starting with the simple interest formula, you should get into the habit of always starting your work by writing down the formula. So I is equal to PRT. Again, we're looking for the interest. So I is going to be equal to the principal, which is $3,000. The rate is 1.5, so we're going to change that to a decimal form. And the time in this case is 5 years. So when we do those calculations, 3,000 times 0.015 times 5, we end up with $225. Now, part B again is future value. So our future value is going to be our initial principal, which was $3,000. We're going to add our interest, which was $225, and we're going to end up with $3,225. Okay, fairly straightforward for most of you, hopefully. The next part is the value of a simple interest investment after a given term can be calculated using the following formula. So now we're looking at A is equal to P plus PRT. Another way to write that formula is A is equal to P times 1 plus RT. All we did in this second formula was factored out the principal and written the rest in brackets. What you should know for this part is that A is representative of the amount earned. So for most of these questions, we're already going to know how much money we want to have at the end, or how much money somebody did end up at the end of a term with, and we're going to have to calculate either the rate or the time. What was their interest rate, or how long did they have that investment for? So, looking at example 2 with that, Ingrid invested her summer earnings of $5,000 at 8% simple interest, paid annually. Almost always, interest is going to be paid annually. She intends to use the money in a few years to take a holiday with a girlfriend. How long will it take for the future value of the investment to grow to $8,000? So for starting part A, we're now looking at the value of a simple interest investment. So our formula has changed slightly. We're using A is equal to P plus PRT. That's the one I'm going to use. If you want to use the one with the principal factored out, it doesn't really matter. It's going to work out the same in the end. So we're wondering how long it's going to take. How long? We're looking for the time or the term for the future value of the investment to grow to $8,000. So $8,000 is our amount that it's going to be at the end. The principal we started with was $5,000. So we're putting that in for principal. Our rate was 8%, so again, we're always changing that to a decimal when we're calculating simple interest. And lastly is the time. That's what we don't know. So now, grade 12s, we're going back to being able to solve equations. I'm going to first do the multiplication right here of 5,000 times 0.08. So I'm going to have 8,000 is equal to 5,000 plus 400t. I now need to work to isolate this t variable. So I'm going to get rid of this 5,000 by subtracting 5,000 from both sides. I'm going to end up with 3,000 then over here and 400t on that side. The next step to isolate t is to divide both sides by 400. And when you divide 3,000 by 400, you're going to get 7.5. Now, something you really have to pay attention to in these questions is how often interest would be paid out or accrued. Here, it tells us that the interest is only paid annually. Because that's paid annually, and the time that she would need to collect $8,000 is 7.5. It's more than a full year, less than a full year. In order for her to collect that last little bit of interest to bring her to the 8,000 mark, she's actually going to have to wait until 8 years. Because if she takes it out at 7.5, she's not going to accrue that last half a year interest because you only get paid out annually. So she would only get paid out for 7 years of interest instead of 7.5. So if she wants that full 7.5 years worth of interest, she's going to have to wait till 8 years. Okay, what is Ingrid's rate of return? That's part B. In order to figure that out, we first have to calculate how much interest she would accrue in 8 years. So I can look at my simple interest formula. I is equal to PRT. Our principal is $5,000. Our rate is 0.08. And our time, we're talking 8 years. And just have to pull out my calculator here. So 5,000 times going to end up to be $3,200. Now, to figure out rate of return, Ingrid's rate of return, right here, if you go back to your notes, we figured out that rate of return was the amount of money you earned divided by your original principal multiplied by 100. So our rate of return here is going to be equal to the amount of money we made, which was $3,200, divided by our original principal, which was $5,000. And then we're going to take that and we're going to times it by 100. So 3,200 divided by 5,000 times 100 ends up being 64%. So she's got a 64% rate of return on her investment in that situation. Try this next one on your own. Again, pause this, take a couple of minutes to work through it. I'm going to continue on with the answer. So Caitlin is a co-op student. She invested her work term earnings at $10,000 at 4% simple interest paid annually. She intends to use the money in a few years to take a dream vacation with a friend. How long will the investment take to grow to a future value of $12,000? And then we need to determine her rate of return. So again, we're looking at this simple interest amount formula of A is equal to P plus PRT. The amount that she wants to end up with is $12,000, and the principal that she's starting with is $10,000. Her interest rate, again, was 4%, so we're looking at that in decimal form, and we want to know how long that's going to take her to do. Now I'm going to do two steps of math here in one. I'm going to subtract this 10,000 from both sides to start isolating my variable, and I'm going to do this multiplication all in the same step. So I'm going to subtract 10,000 and end up with 2,000 over here. And then I'm going to also multiply 10,000 by 0.04, and I'm going to get 400t. To isolate my t variable, I need to divide both sides by 400 because 400 is being multiplied by t. 2,000 divided by 400 is 5. So that's what my term is. It's going to take her 5 years for her $10,000 to grow into $12,000 at that simple rate of interest. What's her rate of return then? Well, rate of return is calculated by how much interest she earned. So in this case, that was $2,000. We need to divide it by her original principal, which was $10,000. And then we're going to multiply it by 100. And we're going to get an answer of 20%. All right. Last but not least, Grant invested $25,000 in a simple interest Canada savings bond that paid interest annually. If the future value of the Canada savings bond is $29,375 at the end of the 5 years, what interest rate does the CSB earn? So we're still looking at the same formula here, grade 12s. The only difference is that now instead of looking for our time, we're looking for our rate. So my formula is going to be the same. My amount is going to equal my principal plus my principal times my rate and time. The amount that it grows to is $29,375. The principal I started with was $25,000. The rate is what I'm looking for, and the time is 5 years. So again, I'm going to do two steps of math here in one. In order to start isolating this R variable, I need to subtract 25,000 from both sides, and I need to multiply 25,000 times 5. So I subtract 25,000 from both sides, and I end up with 4,375. And 25,000 times 5 is 125,000, and I still have that r variable. Now to get r by itself, because they're being multiplied together, I divide both sides. I can show that here. Divide both sides by 125,000. And 4,375 divided by 125,000 is 0.035, which is what r is equal to. If I change that to a percentage, that means I have to multiply it by 100, and I end up with 3.5%. Part B of this says, Grant cashed in the bond after 4.5 years. How much money did he have? So again, I am looking for the amount of money that he gets. So I'm using the same formula. This time it's the amount that I don't know. So the principal that he started with was 25,000. The rate he's using is 3.5, so 0.035. Now the only kicker here is they're trying to trick you with this 4.5 years. Remember what I said earlier, you have to be careful. You need to see how often interest is paid. Here it says interest is paid annually. That means that until that full year is up, you're not going to collect the interest that was accumulated during that year. So because he cashed in his bond after 4.5 years, he's only going to get the interest that he accumulated up to the 4th year. So we can only put in 4 as our time here. If I can write back in here. Because that half a year interest he's not going to get. If he wants it, he's going to have to hold that Canada Savings Bond until 5 years. So I do these calculations. I get 25,000 plus $3,500, which is equal to $28,500. Okay, last question on your own. Give it a quick pause. I'm going to work through it for the answer. How would the interest rate change in each situation? So if Grant invested a principal of $20,000 instead, and the CSB grew to $29,375 in 5 years. So I'm starting with my same formula. The amount that he's getting is the same as we started the last question with. The principal here, though, now has changed. The rate is something we're looking for, and the time is still 5 years. I'm going to subtract 20,000 from both sides, so I've got 9,375 is equal to 100,000 R. I'm going to subtract by 100,000, and I'm going to get 0.09375, which is equal to R. I change that to a percentage, and R is going to be 9.4%. Okay? In part B, if it took 8 years for Grant's principal of $25,000 to grow to $29,375. So the amount he's ending up with is staying the same. His principal is going back up to $25,000. This time, it's taking 3 more years, though. So again, I'm going to subtract 25,000, and I'm going to get 4,375. 25,000 times 8 is 200,000, and I still have that rate that I'm looking for. I divide both sides by 200,000, and I'm getting 0.021875, which as a percentage is this should be 0.021875. So I'm looking at 2.2%. So how would the interest rate change? Here the interest rate is going way up. from 3.5 to 9.4, and here the interest rate is going way down from, well, not way down, but quite a bit down, 3.5 to 2.2. All right, hopefully that was pretty straightforward. I want you to work on some textbook questions right now, pages 14 to 17. In 4 to 12, I want you to choose 3, and then I want you to try 13 and 14 as well. I will be doing a check on these questions tomorrow.